Dr. R. Hemavati is an assistant professor in mathematics in Queen Mary's, Chennai. She has specialized on functional analysis. Having 12 years of experience in teaching, she has won various awards for her performance. She has published papers in 14 international journals, 3 national journals, and has presented papers in 10 international and in 5 national conferences. She is also one of the editors for an international journal.
Welcome to UGC lecture series. As discussion about in the previous sessions, we were discussing about various components of time series analysis and discussing about the next component of time series, seasonal fluctuations. We have been calculating seasonal fluctuations by the method of simple averages and by the method of ratio to trend method in the previous sessions. In continuation of that talk, in this session we are going to talk about the seasonal variations calculation by the method of moving averages and link relatives method. So, first of all, ratio to moving average method. The ratio to moving average method, also known as percentage of moving average method, is most widely used method of measuring seasonal variations. The steps for determining seasonal pattern by this method are: first, eliminate the seasonality from the data by ironing it out from the original data. Since seasonal variations recur every year, that is, since the fluctuations have a time span of 12 months, a centered 12-month moving average tends to eliminate these fluctuations. In case of quarterly data, a centered 4-quarter moving average must be used. The centered 12-month moving average, which aims to eliminate seasonal and irregular fluctuations, represent the remaining elements of the original data, namely trend and cycles. Thus, centered 12-month moving averages approximates trend and cyclical variations. First of all, express the original data for each month as percentage of the centered 12-month moving average corresponding to it. That is, writing the values corresponding to the year, that is very important. Okay, so, first of all, express the original data for each month as percentage of the centered 12-month moving average. Divide each monthly item of the original data by the corresponding 12-month moving average and list the quotients as percent of moving average. Now, we have now succeeded in eliminating from the original data to a considerable extent the disturbing influence of trend and cyclical fluctuations. So, it remains to get rid of the data of irregular variations. By averaging this percentage for a given month, the irregular factors tend to cancel out and average itself reflects only the seasonal influence. So, the purpose of this step is to average and in progress of averaging to eliminate the irregular factors. So, first of all, when you take the 12-month total and center it, the influence of trend and cyclical fluctuation goes out. So, to get rid of the irregular variations, we average and center it, therefore, the irregular variations also goes out of the original data. Therefore, in the original data, when trend, cyclical and irregular variations goes out, there remains only seasonal index. So, we assume that relatively high or extremely low values of seasonal relatives for any month are caused by irregular factors. That is why we take the average and percentage it. So, it becomes a value above 100, therefore, only seasonal fluctuations are the cause for that. So, the elimination of extremes may be achieved when while we are averaging like January's for the years mentioned. Similarly, February for the years mentioned and the like. We do this by using an appropriate type of average. The median is appropriate, that is why it is centered. Center values is always called as median values. So, the median is appropriate since it is not affected by extremes. Thus, By using the median as an average, we can obtain typical seasonal relative for each month, which will not be affected by irregular factors. Sometimes so called modified mean is used as an average for each month. Here extreme values are omitted before the arithmetic mean is taken. So, in an array of seasonal relatives for each month, a value of seasonal values on one end or both ends may be dropped, and then the arithmetic mean for the remaining seasonal relatives is taken. A separate table is prepared in which the calculations involved in this step are shown. These means are preliminary seasonal indexes. Now, whatever the steps now I am just reading out, you do the problem and just come to the steps and go through, you will understand it very clearly. So, they should average 100% or total 1200 for 12 months by definition. If the total is not equal to 1200 or 100%, an adjustment is to be made to eliminate the discrepancy. The adjustment consists of multiplying average of each month obtained in step 4 by 1200 by the total of the modified mean for 12 months. This adjustment is made not only to achieve accuracy, but also because when we come to eliminate seasonality from the original data, we do not wish to raise or lower the level of data unduly. Thus, if a seasonal index aggregates more than 1200 or averages more than 100, then original data adjusted in terms of it will total less than the unadjusted original data. So, if it totals less than 1200, the opposite would be true, that is for the unadjusted original data. So, the logical reasoning of finding seasonal index is behind this method is from the fact that 12-month moving average can be considered to represent the influence of a cycle or the trend, cycle into trend. So, if the actual value for any month is divided by the 12-month moving average centered to that month, presumably cycle fluctuations and trend values are removed. So, this may be represented by the following expression, that is a trend into seasonal into cyclical into the irregular variations is the multiplicative model of the original data. Okay. If we center the 12-month moving averages, then obviously trend and cyclical fluctuation goes out means it will be automatically divided, and then we get seasonal into irregular. Thus, the ratio to moving average from this method gets its name, represents irregular and seasonal influences. If the ratios for each worked over a period of years are then averaged, that is all the averages are then averaged, then most random influences, that is irregular variations, also will be eliminated. Hence, in effect we have S into I, that is what is remaining. When we take the average of averages, irregular variations also goes out and we get only the seasonal variations. Now, the following table given is for 12 months and for the years 2007, 2008, 2009 and 2010. The values given here are split into so many slides because all the values cannot be shown in one slide. So, you have to understand. The question is apply ratio to moving average method to ascertain seasonal indices. Now, actually calculating seasonal index is one way, means eliminating the trend, cyclical and irregular variations. Then there remains S, that is how seasonal variations are usually calculated. There is no such big method like we have in trend, like method of least squares, etc. So, what is the main thing is we eliminate the values of trend and we eliminate the factors cyclical and irregular from the original data. So, T, S, C, I, when T, C, I are divided, we get only S, that is the seasonal variations. So, the question given is for sales in 1000 units for the year 2007 starting from January, February, March to December. Okay. So, the values for the year 2007 is from 10, 12, 13, 15, 16, 16, 17. 18, 18, 19, 22 and 22. Okay. Similarly, for the year 2008, the values from January to December is from 11, 11, 12 etc. up to 20. Okay. Then the values for the year 2009, January value is 10, 12, 11, 12, 13, 15, 15, 17, 18, 20, 22, 24. Similarly, the values for the year 2010 if from January to December is from 12 to 25. Now, first of all, for computation of 12-month moving averages, just write down the values vertically like this. Starting from 2007, January, February, March, April, May, June to December, and then starting from 2008, January, February to December, then starting from the year 2009, January to December, starting from 2010, January to December. The values are written vertically. It is going to be a very big tabular column, therefore, it is written vertically. Totally for the 4 years, each year 12 values. So, 48 values are written vertically now. Now, the 12-month moving total, 12-month moving total is written here, that is 198 is the total of the first 12 values. So, remember 48 values are written vertically starting from 10 to 25. So, totally 48 values are written. First of all, 12-month moving total, that placing it the value in the proper place is very important. That is the first 12 values. Let me read out what is the first 12 values. 10 plus 12 plus 13 plus 15 plus 16 plus 16 plus 17 plus 18 plus 18 plus 19 plus 22 plus 22 gives you the total 198. Okay, 198. This 198 is written in between the 6th and 7th, in between the 6th value and 7th value, that is between June and July of the year 2007. Okay. So, between 16 and 17 it is written. So, the value is 198. Okay. Similarly, the next total is 199. This 199 is leaving the first value, very important, leaving the first value 10, take the total of the remaining 12 values. Relieving the first value, take the total of 12 values, leaving the first value, taking the total of 12 values is 12 plus 13 plus 15 plus 16 plus 16 plus 17 plus 18 plus 18 plus 19 plus 22 plus 22 plus 11. This is 199, and it has to be placed in the middle of second value to 13th value. That is, the middle of second value to 13th value happens between 7th value and 8th value. The 7th value and 8th value is between July and August, and in between it is written, it is 199. Okay. Similarly, 198 is calculated by leaving out the first two values and then taking the total. Likewise, the values are calculated up to 25. 12-month moving average, this is 198 divided by, because 198 is obtained by taking the total of 12 values. So, average will be total of 12 values divided by 12. Total of 12 values is 198. So, divided by 12 gives you 16.50. Similarly, 16.58 is 199 by 12. Similarly, 198 by 12 is 16.5. Likewise, this is calculated. Then 12-month moving total of column 4. Moving total means you have to adjust and write the 16.5 is not representing any month, right. It is written just in between June and July, it is not representing any month. The value 16.5 and 16.58 has to be centered, How to be centered? 16.5 plus 16.58 is written first of all. 16.5 plus 16.58, this is equal to 33.08. 33.08, and then that is written in between the middle of the two values. So, actually when you see 16.5 is written in between June and July, and this 16.58 is written in between July and August. So, when you just center the two values 16.5 plus 16.58 and the center is July. For example, let me explain with the 16.5 and 16.42, and this value is obtained by eliminating the first 4 values and taking the after 4 values fifth value to 12 values. Okay. So, 197 by 12 is 16.42. Now, how to center these particular values is not representing any month. So, how to center it? Center it in the sense we have to just add 16.58 plus 16 is again 33.08, and then here 32.92 is 16.5 plus 16.42 is 32.92. Likewise, this is calculated and it is written against July, against August, because these two values 16.58 plus 16.5 total is 33.08 and it is written against August. Similarly, 16.5 plus 16.42 is written against September. This is 32.92. Now, what does this tabular column stands for? Next tabular column, column 6 is centered 12 month moving average. That is what is called centering. Centering in the sense it should be representing some month or some quarter or some year. Okay. So, centered 12 month moving average is column 5 divided by 2, because whatever the value you are having 33.08 is obtained by adding 2 values. So, average will be taken as the total value divided by 2. Okay. So, that is 33.08 by 2 is equal to 16.54. Similarly, 33.08 by 2 is equal to 16.54. Similarly, 32.92 by 2 is equal to 16.46. So, likewise the values are calculated. Then, how to obtain percentage of a centered 12 month moving average? Percentage of centered 12 month moving average is obtained as column 2 divided by column 6. Okay. The centered 12 month moving averages are obtained, and these are the values representing the seasonal index along with the irregular variations. So, when you take the percentage, you just eliminating the irregular variations also. So, this value will be only seasonal variations. So, now corresponding to 16.54 is the first value calculated for the month of July. When you are centering the values, there are no values for the month of January to June. Corresponding to the year 2007, for the month of July it is 16.54, whereas the actual value given is 17. Therefore, this 102.8 is 17 is the actual value given, and 16.54 is the value which you have calculated. 17 divided by 16.54 into 100 is 102.8. Similarly, 108.8 is 18 divided by 16.54 into 100 which you have calculated, and this value is 18 by 16.46 into 100 is 109.4. Likewise, all the values are calculated. Next, computation of a seasonal index. Whatever the values you have calculated for the corresponding years are written in this manner. That is, for the year 2007, that is the starting year 2007, as I told you, there are no values for the month of January to June. The values start from July only. The July value is 102.8, 108.8, 109.4. So, these values are written in this format. 102.8, 108.8, 109.4, 116.3. So, the values which we have calculated is 102.8 to 98.8. Okay. So, these values are just out of 48 values. In the year 2007, 6 values are not there, no. So, similarly, in the last year 2010, the last 6 values will not be there. So, totally out of 48 values, 12 values are not available. Not available in the sense when you are just writing it in the format, the first 6 values will not be there and the last 6 values will not be there. So, totally 12 values are not there. So, this 102.8 starting from 102.8 to 98.8 are the 36 values. Out of 48, when 12 values are not there, 36 values are just written in this format. Okay. So, after that you just calculate the median in the sense center value. Okay. How do you find out the median? First of all, arrange the values in either ascending order or descending order and take the middle value. Okay. When there are 2 midpoints, just take the average of the midpoints. So, the median here is talking about the January month for the year 2007, 2008, 2009 and 2010. There are only 3 values because for the year 2007 there is no value. So, 69.5, 70.0, 70.1, as such it is arranged in the ascending order, that is 69.5, 70, 70.1. The middle value is 70.0. So, the median is 70.0. Okay. The next value is 70.4, 83.3, 74.5. These 3 values are not arranged in ascending order. Therefore, when you arrange it in ascending order, the order is 70.4, 74.5, 83.3. Among the middle values, the 74.5 is the median value. So, 74.5 is written here. Similarly, this is arranged in descending order, as such the descending order, therefore, the middle value is 75.2. Likewise, the median are calculated, that is 1196.2, the value is less than 1200 and we just calculate the median. The sum of 12 values obtained is 1196.2. It is therefore necessary to make an adjustment so that the total is 1200. So, the adjustment is done by multiplying the average values by the average median values by that. So, 1200 by 1196.2 is the average of median values is 1.003. So, the final result thus obtained gives the seasonal index. 1.003 is the adjustment we have made. So, 70.28 is obtained as the adjusted seasonal value, 1.003. Next 74.5 is adjusted with 1.003 as a 74.8 and similarly 75.2 is adjusted with 1.003, that is 75.5. Similarly, 83.7 is adjusted with this 1.003, we get 84.03. Likewise, this is calculated. Now, when you take the total comes to be 1200.68. Therefore, it is nearly 1200 and it is acceptable. Therefore, for this problem, the seasonal index is starting from 70.28 to 140.56. In this session, we talked about calculation of seasonal indices by the method of ratio to moving average. An illustration was done wherein we have centered the average values. Centering the average values means eliminating the cyclical fluctuations so that the remaining seasonal index will be calculated. Based on the discussion in this session, the following question may be posed. Apply the ratio to moving average method to evaluate the seasonal index for the following data. Year and month of the 3 years have been given. Year and month of 2002 starting from January to December has been given, and similarly year and month of the year 2003 starting from January to December has been given. Similarly, year and month of the year 2004 from January to December has been given, and the number of persons visiting a place of interest in all the 3 years have been given. Number of persons visiting a place of interest in the month of January in the year 2002 is 90 members. Like that, the values has been given, 36 values are given here. We have to find out the ratio to moving average method to find seasonal index. Thank you.